Welcome, everyone. Thank you for joining the webinar, How to Maintain Your Baghouse, presented by Minority Filters. This is the first event in our webinar series. It will include a presentation by two filtration experts, followed by a live question and answer session at the end. If you would like to submit a question, then at any point during the presentation, please type your question into the chat module. Now, I'd like to introduce your presenters. Dave Thompson is the technical director for Minority Filters. He has 37 years of experience in all aspects of filtration. He's a certified team leader for Kaizen and previously served 4 years in the Marine Corps. Michael Goff is the national sales supervisor. He has 14 years of experience in the industry with a focus on solution strategy, planning, and coaching. So without further ado, Dave, take it away.
Great. Thank you very much. And good morning, everybody. We really appreciate you being here. And what Michael and I are going to do here over this next 45 minutes or so is walk you through the various aspects of baghouse maintenance so that in the end, you'll have a better understanding of how the health of your baghouse can help extend the life of your filter bags and increase the efficiency of the overall operation. We at Minority, we look at these inspections as something that's done on a daily basis, weekly, monthly, quarterly, and annually. And obviously, as you go out further, they become a little more in depth. But we're going to go over each one of those so that you have a good understanding of what we consider to be good engineering practice and good housekeeping to keep your baghouses running correctly. So what we recommend is that you walk through walk through the baghouse area to check for abnormal or normal sounds and audible and visual oddities or normalities that might be involved in the system. So that as you go through, you listen for the valves that are actuating, for any dust that may be in the area or on the ground. So as a part of that, we always go and we record daily the pressure drop across the system. We want to monitor the gas flow to make sure that you've got the right flow of gas coming through the system. We want to check our cleaning cycle. Again, look at our valves and our length and duration of the cleaning cycle. We want to make sure that our compressed air traps and so forth are drained and dry, so that the pulse jet air is as clean and as dry as can possibly be. We want to monitor our discharge systems, the rotary valves, and the debris, so that it leaves the housing in a normal way. Our screw conveyors, our air slides, our drag chains, and so forth. And then we also want to observe the plume opacity out of the stack, so that we make sure that we're not causing any problems. Visual and audible inspections.
Thanks, Dave.
Sure.
This is Michael. Thanks for everybody for joining us. As far as a weekly check is concerned, this is just a good list to get you guys started. We recommend you look at your bag seating conditions, spot check for holes, leaks, moving parts on your shaker system, hoses, clamps. The pictures you see there to the right indicate some common problems that you might run into: pinholes, bags not seated correctly into the tube sheet. And it's not a thorough inspection, a weekly inspection. It's just an opportunity for you guys to crack the door and take a look and see what's different week after week. So from a bag seating perspective, this is a good picture of the picture to the right of a reverse air bag seated onto a thimble. And then the diagram to the left just kind of goes over what an improper seating of a filter bag might look like. You see there in the picture to the right, the bags are kind of cattywampus. They're maybe cross thread a little bit on the top bead of that thimble. So we don't want the bags pulled all the way down to the tube sheet. We don't want the bags crooked on the thimble. That picture bottom to the right, we just want a good seating where the top bead of the thimble and the bottom rope of the bag creates a gap just wide enough for you to install a nice new hose clamp or line clamp, whatever you guys choose to do. And then the picture there with the corroded clamp, you know, these bags, we want them to run as a natural life cycle as they can. We don't want premature failure of a $100 bag or something caused by a $10 clamp. So I know a lot of folks, part of their preventive maintenance is to change out these clamps each time. We would at least recommend taking a look at them to make sure that those are in good shape. Any corroded clamps during your weekly spot check, let's get those out of there and get them replaced. Shaker baghouses, you folks out there that have experience with shaker baghouses, they're the oldest type of baghouse out there. You know, there's a lot of mechanical arms, motors, actuators that are moving around. That's what causes these things to clean. And don't just take for granted that because that motor is turning, that those shaker bars are moving. Please take an opportunity to look, make sure that everything is lubricated, and even though that motor is turning, make sure that the bars are actually cleaning the bags.
We move on to the monthly inspections, and just to build on what Michael was telling you. So we want to spot check certain things inside the baghouse, especially in reverse air bags and shakers. You want to check the bag tensioning. You also want to blow out the manometers and the magnehelic lines for your differential pressure gauges so that you get good readings and that you can rely on the information you're getting from your gauges. You want to verify the working temperatures and of the system. You know, we know that one of the biggest problems with baghouses is that, you know, temperature spikes can really chew into the life of a bag, and premature failure can happen if you get temperature spikes often, and if they're long in duration. You have to be very careful. So you want to make sure your temperatures controlled properly. You want to check all your compressed air lines to make sure that you're getting the right amount of air, so that you in pulse jet systems, so you can back pulse the systems, and that the air is dry, that you're not creating moisture when you go to back pulse and clean your bags. You want to check the bag sequencing, and this goes back to the valve actuation and so forth. So you want to make sure that you're sequencing in asymmetric order, so that you're going, say, row 1 and row 5, row 2 and row 6, row 3 and row 7, and so forth, so that you're never cleaning a row of bags next to a row of bags that were just cleaned, because all you're going to do is refoul those bags, and you're going to have a high differential pressure. You're going to end up with premature bag failure, and your system's not going to work efficiently. You want to make sure that they're sequencing properly, and that you've got the right intensity and duration in your back pulse. And then you want to check all moving parts in your discharge system: rotary valves, screw conveyors, pneumatic conveyance or air slide, and drag chains and so forth. We find that if these things aren't operating properly, bags can end up sitting in ash. You can end up getting baghouse fires and so forth. So you want to make sure that all of the ancillary things around the bags are working properly to give your bags the best chance of operating for their full life and giving you good efficiency throughout that life. Just a few photos to talk about, you know, what you're looking for when you walk into the upper right hand box. You've got a spring on a reverse air system that is broken. It's collapsed. That bag is probably not got enough tension in it. It's not going to clean properly. To the right, on the bottom right, you'll see a system where it looks like it's working in good order, and that the springs are not broken, and so you'll have the best chance of cleaning that bag and getting it back online with a lower differential pressure and a good long interval between cleaning cycles. Top left corner is a shaker system. You want to make sure that the bags are seated properly in the tube sheet, and that they are working properly with their shaking system to clean properly. little things that you can look at that will make a difference. And these things should stand out when you walk into a baghouse or you check out the upper part of the baghouse where all the mechanics are involved in the reverse air and the shakers. Um, One of the things that we recommend, and it might seem like a little bit much, but it really is something that pays off in the end, is that we want to make sure that our differential pressure gauges are working properly. And so what we recommend is that you take a new gauge or a gauge that's been recalibrated out with you when you make your monthly check, and you disconnect the hoses on the baghouse and you run those hoses back to your new differential pressure gauge. If the reading on the new gauge checks with the reading on the old gauge that's on the housing, then you've probably got a good gauge on the housing. If they don't check, then you've got to look at that differential pressure gauge and possibly replace it or repair it. These are little things, and delta P is a real problem in baghouses. Any of you guys that are maintaining these things, you know that it can be an issue, and it's never a slow creep. When it's a problem, it happens instantaneously almost, and you end up with catastrophic failure of bags and cages and so forth. So it's real important that you go out and you check your gauges and so forth. Talk about making sure your compressed lines and air lines are clear, and your oils and oil filters and so forth, or oilers and filters are working properly. We know that plenty of compressed air systems create moisture, and if they don't have a desiccant dryer on them, which we recommend for every system like this, but some don't, you get a buildup of condensate or moisture in the lines. It begins to cause a problem, so you're blowing wet air across your bags, and you're not getting the volume of air that you need. So it's real important to check these lines. You also want to make sure, again, to check your temperature measuring equipment. Make sure that the readings are valid and that you're not you're not running your bags at a higher temperature than specified. For pulse jet cleaning systems, again, the valve, the sequence of the cleaning, the duration, and the intensity of the airflow is all critical. And these valves can be heard as you walk through the plant. You can listen to them firing. You can put your hands on them to check the sequencing to see what the sequence is, so you can actually feel it in your hands with how they're operating and what sequence they're firing in. And then if you've got situations or problems with that system, quite frankly, they're easy to repair. It's just a matter of going out there and making sure that you find any problems that are out there, because they can go undetected. You may hear it from the ground as it fires and it cleans, but you want to make sure that it's doing that in the right order with the right intensity and the right duration. The blast on a pulse jet bag is a very robust, short blast of air. If you hear the long, drawn out blast of air, that's got maybe high volume but low pressure, there you have an issue. So you want to make sure that these are firing properly. Easy to check. Other things that are involved with your cleaning system that could be a cause of a problem or an area that needs to be checked are your timer boards to make sure that they're functioning properly. A broken or damaged timer board will foul your system and make it so that it doesn't sequence properly. Valves that need new repair kits, diaphragms and springs and so forth can easily be fixed. We sell those types of kits and timer boards to make sure that all of your valves are in proper working order and give you exactly what you need when you need it on demand. Remember, all that compressed air that you're generating, it costs a lot of money. If it doesn't get to where it's supposed to get to in a timely manner, at the right intensity and the right duration, it's not going to help you at all. So we want to make sure that your valves are working right and your timer boards are in good shape. Lots of people use remote sensing and so forth on their system, so they can look at through radio frequency their cell phones and see what's going on with systems. You want to double check and make sure those systems are working right. Don't take it for granted that they're working. There could be a problem that's hiding beneath and you don't know it. So you want to make sure that they're working properly, so that you give your system the best chance at operating efficiently. Get into especially for bulk pulse jet housing baghouses, the whether you're cleaning on demand or you're cleaning continuously. We recommend for overall life and health of a baghouse that you clean on demand. You only clean when necessary. Again, compressed air is expensive, so we want to make sure that when it's used properly. It gets to where it's supposed to go and it does its job. So we want to make sure that you're setting a high and a low differential pressure on your gauges, that it cleans only on demand through those set points, and that will give your bags the longest and the best possible chance of lasting a long time and not failing prematurely. Over pulsing a bag will do several things. If it's a bag that requires a dust cake, it'll pulse the dust cake right off, and then the bag won't function properly. If you over pulsing will create a lot of friction between the bag and the cage, and it'll wear the bags out prematurely from the inside. So you want to make sure you do that. In systems where you're cleaning on time, you want to make sure that you're not cleaning too often, so that if you have a dust cake, you don't push that dust cake off. So you need to know the type of media that you're using, and then choose the type of cleaning sequence that's going to work best for your system. Again, we do recommend in most cases cleaning on demand.
Yeah, thanks, Dave.
Yep.
From a quarterly standpoint, if your system can allow it, your process can allow it, we recommend a thorough inspection of all your bags. So if you can do a leak detect tests, this will be a great time to do it. We'll calibrate your opacity monitoring equipment. This will be your probes if they need cleaning, air in leakage, gaskets, doors, airlocks, screw conveyors, things like that. We'll spend a little bit of time on this, but most of the time, you guys are going to be working on negative pressure systems. So if you've got a stack with a fan on the back side of a baghouse pulling air through the collector, it's a negative pressure system. In those type of systems, those baghouses are meant to operate under vacuum. So anytime you have air in leakage, depending on where the leakage is, you're either going to be robbing draft, or you're going to be introducing ambient air that's not supposed to be there. All kinds of things. We'll go over that. We're inspecting the paint on the baghouse, just noting any corrosion, baffle plates for wear, reverse air collectors, just observe the dampers to make sure that those are seating properly, that those plates haven't worn down, and that you're able to watch your differential pressure. Once those things are in place, you can actually get to a zero set point. That's important to make sure that those things are cleaning properly. And then inspecting fans, screw conveyors, airlocks to make sure that those are operating properly. The opacity monitoring system. This is really you only really need to calibrate the older units, DC or AC only. If you're using a newer unit from somebody like Auburn Filter Sense, those things really don't need periodic recalibration. Those are good to go. But depending on the application, how sticky your product is, the velocity, several different factors. From time to time, you might need to clean that probe that's in the ductwork that's measuring the particulate going by. So that's something that we can help you with. Air in leakage, access doors not sealed, holes in the housing, holes in the ductwork, slide gates, so on and so forth. So here's a few pictures. I talked about a little bit about it a couple of slides ago, just in general. Here's some pictures that kind of bring it home a little bit. The picture on the left is, of course, a hatch door for a reverse air collector. You see that door gasketing is pretty well worn out. And you see the metal flaking and corroding around the doors, the door edges. So in this instance, you're going to have air and moisture and whatever's outside of the collector going in at this point, leaking into the compartment, and it's going to go by the bags. It might condense some of the gas stream to create some acids that are not supposed to be there interacting with the bags. So in this picture, air and leakage might be hurting the bags. The picture bottom right is actually a pulse jet unit with some liftoff doors. So this, if you have leakage here, that leakage and gas stream that is coming into the collector may not interact with the baghouse. It may condense a little on the top side, but it's actually going to be robbing your system of draft. So imagine the fan on the back side of the collector trying to pull air through this entire system, which starts all the way up at your combustion source or your hood. You know, that ductwork, those hoods, all that velocity is designed for all this to be sealed up. So a fan doesn't care where it's getting the air. It would much rather take the air right here next to the fan than have to work all the way through the tube sheet and the bags and the turns and the ductwork and so on and so forth. So leaks here will cause, you know, air to be robbed from the entire system. These are just some examples of door gasketing. So door gasketing is much like filter bags. There's a different filter bag for every application. There's lots of different door gasketing types. Types dependent on, of course, the door and baghouse seal, whether it's a hatch door or a lift-off door or a lid. And then it's, to a great extent, dependent on temperature and chemistry and how much compression, how much memory you need these things to have. So door gasketing is one of those things that is easily neglected, forgotten maybe. But if you guys have a couple 100 feet in your storeroom, does not have a shelf life, just keep it ready to go. Anytime you open the collector to doing an inspection, please make this part of your inspection and just have it ready to go. So I don't know if you guys can see this screen. On my screen, we should be talking about baghouse. I'm sorry, go ahead.
You can't see it, Michael?
I cannot, but we should be talking about baghouse inlet challenges. So baghouses, where your inlet ductwork comes in, bringing your air and gas stream into the collector. Typically there is a diffuser plate there or some angle plate. Sometimes it's perforated holes, sometimes it's concentric rings, turning vanes, all kinds of different things. The point behind this is, guys, is these baghouses are engineered from the OEM with these diffuser plates in mind. These diffuser plates serve a solid purpose for these baghouses. It helps to orient both the air and the particulate evenly throughout the baghouse, so that one section of the baghouse or one section of the bags is not constantly getting pounded by most or all of the gas stream. Okay, so if you were in the ductwork, in the inlet ductwork, looking out, you should see something, whether it's a perforated plate, or some angle plate there to help redirect the airflow. This is a picture of a couple of different designs. You see the picture on the left is something that we call a Casket Air Diffuser. It is supported, patented by one of our sister companies, Micropool. And if you were in the ductwork looking into this, this would look like a solid wall of metal. What it is, it's larger rings moving down to smaller and smaller and smaller rings as you get into the get further into the hopper. And so what this is designed to do is to peel off a layer of the gas stream as it hits each ring, throws the air and the light particulates up to the bags, and drops the heavy particulate out down into the hopper. The picture to the right is similar in concept, but just different in application. This is a perforated plate, basically the entire sidewall of the collector. The purpose of both of these things, again, is to slow down the velocity and reorient everything evenly throughout the baghouse.
And so to expand on what Michael's talking about with diffuser plates and redistribution and orientation, uh, reorienting the flow of the gas. Here's a photo that shows a perforated plate at the inlet that has been abraded and worn away by the incoming gas and whatever's in the gas stream. If you look to the right, the bags that are in the circle and one just adjacent to that, to the bottom of that circle, you see three bags that have been worn out due to abrasion from the inlet stream coming in and hitting those bags directly, and in a short period of time wearing them out. Now you see only three bags from this photo that are compromised, but those three bags have now compromised the entire system. So what happens is now you've got a fouled bag. All those bags are fouled because the particulate gets up into the clean side plenum, and then is through back pulsing is then pushed back down into the bags, and it begins to back blind the bags from the inside. So these bags will fail prematurely in pretty short order. So upon inspection, if you go into a baghouse and you see where your deflector plate is wearing and it may cause problems down the road, you want to look at getting someone in there to fix that. Deflector plates, our sister company Micropole, they can go in and they can go in the baghouse and change the diffuser plates or deflector plates to better suit the application. You know, these are engineered when a system is put in new. Quite frequently, systems change and velocities change and particulate in the gas stream change, and all those things happen, so that sometimes what you have in the beginning is not what you need in the end. So this is a part that can be changed. Deflector plates can be reoriented or changed completely, just so that you get better life out of your bag and better distribution of air. One of the big things for these is to help drop out the heavy solids. If you've got a solid that's got a high specific gravity, you want the heavy stuff to fall. These help to do that. They help to knock it down and drop it in the baghouse, so they never see the bag. So it's real important when you're doing your inspection to make sure you notice these sorts of things at the inlet, so that you don't come up with a catastrophic failure down the road and you change a bunch of bags and 3 weeks later your diffuser plate breaks and the whole baghouse is fouled and you've got to do it again. It's food for thought. One of the areas Michael touched on before was rotary airlocks leaking. We see this often. The rotary airlock is an integral part of the system and is critical to moving the particulate away from the system once it's been cleaned and backpulsed or moved off the bags, and it's deposited into the hopper. If these leak, then you will get air coming in from the backside, and you'll foul the backside of the system, and you can bring moisture in and so forth. But if these aren't working properly, if they're not properly maintained and oiled, and the bearings aren't working properly or worn out, you'll have a system that won't move material out in an efficient manner. And one of the biggest problems we see in baghouse operation is that you can't get the solids out of the baghouse fast enough. There always seems to be a hang up, and whether it's the rotary airlock or the screw conveyor or whatever it may be, or just bridging of material inside of a hopper. So important to note. And although Minority does not make rotary airlocks, we can help you get people that can repair these things. You can bring in your OEM to look at them, but we do know that they are an integral part of the system. If they don't work right, your bags have less of a chance of working for as long as you want them to work, and to be efficient for as long as you want them to be efficient. Get into the actual moving of the material outside the rotary airlock to the screw conveyor, the drag chain, or the air slide type system. Again, an integral part of the system. If you cannot remove the particulate from the hopper after it's been cleaned and taken out of the gas stream, then your system's not working properly. It's becoming inefficient. You're working against yourself. So to a good inspection of these areas is important. If you see leakage around them, if you see solids pouring out onto the ground around them, you know that there's a problem. Something to be real careful about, and to be sure that you check on a regular basis. The fans in the system, typically, as Michael said, these are negative pressure systems where they're pulling the air through the system. If your fan's not operating the way it should operate, if you've got bent fan blades, rusted internal components and so forth, seal rings aren't working right, you're going to have a system that's inefficient. If you can't push the volume of air through the baghouse at the rate that you need, you're not going to get you're not going to get real good deposition of the particulate on the bags, and you're not going to have the proper cam velocity or interstitial velocity to move the stuff off the bag once it's been back pulled. So it's important that your fans operate efficiently and at the rate that they were designed to operate at. Real important. Troubleshooting your fan. So you want to check the mechanical condition of the fan. This is a good point to make. Drive belts that are loose or out of alignment can result in as much as a 20% decrease in fan speed. That 20% decrease in fan speed can directly be related right back to the efficiency of the system. And if you're not getting what you need as far as the flow rate at the inlet and air moving through the system, it's not going to clean properly. It's not going to deposit particulate properly, and it's going to be very inefficient and cost you money. So you want to make sure you do a thorough inspection of your fans on a regular basis to make sure that they're kind of the lifeblood of the system. If your fans aren't working properly, your system's not working properly. Michael, I'll pass it on to you.
Okay, thank you. And I know it's a lot of information, guys. We will have a summary recap at the end. But like Dave started the presentation, the further you get into the inspections, kind of the longer, the more thorough the inspections become. So on an annual basis, we're just checking bolts, structures, welds, ductwork, buildup, blowpipes, hopper wear, things like that. Your high wear parts on cleaning systems, acoustics, sonic horns, hopper level probes, and we'll talk some about your bottom load collectors that could use an inspection at least once a year. Tube sheet cracks. These can be kind of difficult to find sometimes. They can lead to a lot of problems, what we call backside blinding or failed emissions, things like that. We had a customer not too long ago that standard operating procedure for them was to just change out the bags once a month. The reason behind this was believed to be their process. Leak detect test indicated nothing going through the bags, no holes in the bags, but it was just believed that it was a problem inherent in this process and in this collector. So that was a lot of money every month to be turning over in bags. So we agreed to come in and do an inspection. Tube sheet cracks sometimes can be very small, so it does take a thorough inspection. An annual inspection is a great time to do this to really get the tube sheet cleaned, swept, even washed sometimes. A half a day inspection on the tube sheet revealed a couple of cracks in the tube sheet that were welded up, and the bag life in that collector went from 30 days to over a year. So the benefit for you guys, once you nail down where those cracks are and repair them, less downtime, less maintenance, longer bag life. As far as welding joints, we're just looking for anything that is obviously corroding, anything that seems to be thinning out, any new shiny spots in a hopper or again at the baffle plates, anything like that. Ductwork buildup. Common issue here. I've got a 50 horsepower fan pulling 4 pickup points to my dust collector. Boss comes in and says, we want to add a new line, or we want to add a new process. My differential pressure is running at 2 inches of water column. So I must have plenty of room in the baghouse. Let's add some pickup points. So we change the 50 horsepower fan out to a 100 horsepower fan and add 4 new pickup points. Your ductwork is sized to carry a certain amount of velocity, a certain amount of grains of particulate, and all that is meant to impact the bags at a certain ratio. And that's all things that we can help you calculate, things like that. But every time you have some buildup in the ductwork, It's just like putting your thumb over your water hose. It increases the velocity of the remaining volume that's going through there. So just be very careful when we're adding pickup points. Make sure you get that engineered correctly. We have a sister company named Nordfab that specializes in ductwork. So if this is something that you guys run across or have some additional questions about, please contact us. We can get you some help. These are just some air velocity rules of thumb. Again, speaking specifically on ductwork and carrying velocity. Again, rules of thumb. It's going to be different depending on your gas stream composition, how much moisture you got in there. Is your particulate sticky? Is it typically dry? But just know that ductwork and that baghouse is designed specifically for your system. So anything lower than design could have material drop out and lay up in your ductwork. Anything higher will cause abrasion and premature wear and all kinds of components in the baghouse. Blowpipes. Dave touched earlier on the cleaning system, how to check your timer boards, solenoid valves, diaphragm valves, all that good stuff. So at an annual inspection or anytime you change out your bags, if you change out your bags more frequently than once a year, take a few minutes to look at the blowpipes. Again, the blowpipes should be, you should have a blowpipe over every row of filter bags in a pulse jet collector, unless it's a, there are certain types of pulse jet collectors that don't have that, but in a typical high pressure system, you'll have a blowpipe centered over each row of bags. The holes, although they just look like they're just a simple hole drilled into a piece of pipe, they do have a reason for being a perfect circle. Anything that's causing an elliptical pattern or any kind of a star pattern, you see the picture there in the middle, that's actually a slotted blowpipe, will cause all that energy that your header system, your timer board, your solenoids, your diaphragm valves, all that is working to push air and cleaning energy down into your bags will get wasted if the blowpipes have misformed holes over the top of the row, top of the bags, I should say. So here's a good picture of that. If you've had to replace your blowpipes, again, please make sure that the center line of that hole in the blowpipe is over the center line of the bag and cage installation. The picture there is what can happen to an aluminum Venturi, a metal Venturi, where a blowpipe is not directing all that cleaning energy straight down into the bag. If those blowpipes are slotted or again starred or elliptical, anything like that, instead of the air and the energy coming out and going straight down the bag, it might go sideways. So if air and dust particulate can sandblast a hole into a metal Venturi, you know what it can do to a filter bag. So again, just at least once a year, let's take a look at your blowpipes. Blowpipe connections, there's really a couple of different really common sizes out there. This is a good thing while you're doing your inspection to make sure that the holes in the blowpipes are correct. These end nuts don't typically get fouled unless they get cross-threaded or something like that. But your nitrile gaskets and those retainer rings, sometimes those get lost. So if that's something that you need help with, give us a call. We can help you out.
Okay, we're going to move on to sonic horns here, and for those of you who may have systems or processes that have some particulate that agglomerates or clings to the sidewalls of your hoppers, you may use sonic horns. And if you don't, and you still have that problem, you may want to use sonic horns. And they're a really useful add-on to your baghouse hopper and your system, because what they do is they help to move that hard to move material out of your system through it's an ultrasonic sound wave, creates vibration that will help to free any material that's hanging up and move it out of the system. Again, systems that have debris that hangs up in the hopper tend to be problematic, and so you want to move that out. With the sonic horn, it's a real good option for doing that. They work off compressed air. So again, you want to make sure you've got good compressed air to run these things, and you want to make sure they run for the correct duration and at the right intensity. Just like if you're blowing down a bag, you don't want them to run forever. They usually run for short intervals and are shut off. They're set on timers, and they work to keep the baghouse clean and the hopper clean. What can be a problem though is they can fail, and even a failed or a broken sonic horn will make noise. So you may walk past it and hear it during your weekly or daily inspection. You hear say, oh boy, the sonic horn's going off. I hear it. Well, that's not. It doesn't mean it's necessarily doing anything. So if you've got one that's worn out, you've got to make sure you get it repaired. And what we're going to show you here is that typical things that happen with these is that there's very few parts in them. And what happens is because of the high frequency vibration and so forth, you get with these, you begin to wear out parts through vibration and so forth. So those worn parts, once you cause a crack, it fails. The item will still make, the sonic horn will still make noise and will sound like it's working, but it's not doing its job. So you got to make sure that you get in there and inspect that. And if it's broken, get it repaired. Typical things that happen are you get shown in these photographs, the wear ring is cut into the driver on the inside wall. That creates a gap and then a space for um, um, irregular vibration and so forth, and it begins to work improperly. And then if you've got other cracks in the system in the top rings and so forth, this is going to cause your sonic horn to fail. They can be repaired and they can be tuned if they're not doing the job you want them to do, or if you want them to do something different, they can be tuned. And we work with a sonic horn company that does that kind of work. So they're a real beneficial add-on if they're used properly, and if they're not functioning, they're just dragging your system down because it's costing you air to run that thing and it's not doing anything. So you want to make sure you make the best use of your compressed air and keep the system as economical as possible. Another good add-on in your system would be hopper monitoring, and you want to in your baghouse you want to make sure that you don't get an overaccumulation of debris in the bottom. These types of monitoring systems help to indicate where you've got a hopper that's holding too much in the way of solids. And hoppers are not holding tanks; they're there to hold the material briefly and feed it down to the rotary airlock, and then further down out to the screw conveyor or whatever the means of conveyance is for the material. These will indicate if you're getting too much debris in your hopper. Well, we've had plenty of cases, especially on long bag technology, where bags are sitting 6 feet in ash and not being moved out, and you foul the bottom of the bag, you can burn them, you can have hopper fire. So these help you to prevent having those types of problems. They're an inexpensive add-on, and they really are. They work quite well, and you can even monitor these from through radio frequency through your cell phone and so forth. So these are a nice add-on, and they're not extremely expensive. Um, uh, Another area of concern during your inspections is bottom load collectors and hub seals. We see plenty of times you go to the baghouse and the hub seals are laying in the top of the clean plenum. They've not been put on properly. They've been misplaced, so they install it without it, and you're going to get leakage. This is a main problem with this kind of a system. So you want to make sure that you do in fact install the hub seals, and that you seal your system properly, just as if you would a top load system, to make sure it's sealed properly in the tube sheet. So it's an area of concern that some people sometimes it gets overlooked. One of a critical area that we look at when we put together bags and cages is how that bag fits on the cage, and we find it to be really important, and it is very important to make sure that the bag is sized properly so that you've got the right amount of pinch on that bag. And what that pinch tells you is that the bag, it allows for the bag to move properly on the cage and to not um, create excessive wear on the bag over time. So if a bag is too tight on the cage, and when the bag is back pulsed, the vibration in the cage will rub against the wires will rub against the bag, and it'll create a condition where you wear the bag out from the inside. If the pinch is too big, then you won't get enough interaction between the cage and the bag. So what you want when that blast of air comes through, it's really just a primer to get the rest of that bag, that cage moving, so that it can help aid in knocking the dust off the bag. Really important part. We give some rules of thumb there at the bottom on the different types of bags and what we believe the pinch should be, and we find that these sizes to be really effective at having an efficient, efficiently working bag system. That pinch is really critical, and it varies depending on the type of material that you're using. But the relationship between the bag and the cage is critical, and it's something that we look at first, typically in most new applications or even old applications. What we can show you here is another area related to bag cage problems. So, you take a brand new bag and you slide that, $50 bag onto an old rusty cage like you see on the left-hand side. And what you're going to have is premature failure. That rust or that corrosion is going to, because it's sharp, it's going to create issues with the bag material. And upon vibration, it's going to move and it's going to wear the bag out prematurely from the inside. So it's real important to look at your cages. You don't have to replace cages on every change out, for sure. However, bad cages need to be repaired or typically replaced, so that bag is given it the 100% chance of working for as long as it can. Remember, it takes one bag to foul a system, one bag to have a hole worn into it, whether it's from the inside out or the outside in, to introduce dirt to the clean side of the plenum and to push that dirt down to reach pulsation and cleaning cycle. That will cause premature failure of the entire system. So be real close and look at closely at the cages for bent wires, broken wires, rust, corrosion, things that are going to cause premature failure in your bag. Real important. It's a simple thing. You've got the cage in your hand, you've got the bag in your hand. Look at the two of them together. If that cage is suspect, replace it. Michael?
Yeah, thanks for hanging in there with everybody. Record keeping, everybody's favorite part, right? Look, all the checks, the monthly, the quarterly, daily, what have you. You just need to have an organized, systematic way to measure that. So we're going to go over a couple of things that we use that might help you. The Baghouse inspection report used to help create a data sheet. And that'll be specific to the type of collector or the type of data that you're trying to acquire, and then failed bag charts. So this is a couple of pages of an inspection report that we use, our field engineers, our regional salesmen use when they come out and look at your baghouses. We're looking to capture your baghouse identification, the OEM of the collector, what type of baghouse it is, pulse jet, shaker, whatever, and then all of the information that we've been talking about. What's the size of the bags in the cages? What's the diaphragm valve? What's the timer board? What's the door gasketing? Things like that. So from this inspection report, we hope to condense that inspection report down to a data form. So you guys in your plants, whether you have one baghouse or if you're a cement plant that has 100 baghouses, you have an engineering library somewhere. So if you have one baghouse, you've got a 3-ring binder somewhere in there with 60 pages of baghouse data. You have 100 baghouses, you got 100 of those. So you can get your recommended replacement parts from these 3-ring binders, recommended airflows, so on and so forth. But you're going to be digging through all of those binders. What we recommend is creating either a single binder for a data form for each collector or each product, or an Excel spreadsheet with a tab for each. So we're hoping to condense all the information off that baghouse inspection report onto one simple sheet here with all the pertinent information on types of bags, types of door gasketing, all that stuff. So it almost becomes a recommended parts list, recommended replacement parts list by part number. This condenses things for everybody. Failed bag charts. You guys are going to run into failed bags. Bags are ultimately meant to fall apart. We just want to get them from new to falling apart and extend that life as long as possible. Not enough people use failed bag charts, I believe. You go into a pulse jet unit that has multiple compartments or one compartment. You want to orient your failed bag chart with where your door is located, where your catwalks are, so on and so forth. And there's different rules of thumb that are applied towards where you orient the seams once you install your bags. So pulse jets, the theory will be that you need to orient them this way. In shaker and reverse air, you need to orient the seams maybe another way. The point behind that and how it relates to these failed bag charts, these bag charts give you a North Star. And so for any of you guys that remember looking at a paper map before GPS and computers, north was always up on your map. Okay, so on a failed bag chart, you want your seam orientation to always be the North Star on your map. So what does that mean? On a pulse jet, let's say you have a failed bag at row D or column D, row 2. If all of your seams are pointed in the same direction and you have a failure at the 3 o'clock position in that row, what's your next bag to inspect? It's the bag next to it at the 9 o'clock position. It may not have a hole yet, but that's the next best place to look. So your hole at your 3 o'clock position is pulling in a disproportionate amount of air, velocity, particulate that may begin to sandblast the 9 o'clock position of the other bag. So again, these failed bag charts are meant to help you guys get in and out of a collector as quick as possible.
Thank you, Dave and Michael. So now we will get into the question and answer portion. If anybody has any questions, you can type them into the chat module now. So the first question is from Chris. What is the one thing that the maintenance crew can replace that will make a big impact on the function if we are limited on budget?
From a budget perspective, I would say the door gasketing on a pulse jet, well, even a reverse air, really. The door gasketing can have a long lead time, but it is one of the most neglected items that we see in the field, no matter where we go. So we talked about the problems that baghouses see when they don't have the right airflow going through the baghouse, or if they have leakage from multiple different places. And door gasketing is just one of those economical, no shelf life, get it, keep it on your shelf. I promise you'll need it.
Okay. And then we have a question from, this was in regards to the quarterly checks. If we plan to perform a leak check test, should we go through a cleaning cycle first, and should we perform a cleaning cycle after the test before starting back up?
Yeah, you can. You should, I think, go through a cleaning cycle and then do your leak check and then run another cleaning cycle. The leak check is going to help you determine, obviously, if there are bags that are leaking, whether it's at the tube sheet or if you've got holes in bags. Once you put the leak check in there, you're going to want to get it off the system, in case, especially if you've got a product that maybe won't tolerate that stuff so much. So yeah, you can run a cleaning cycle before, run the leak check, and then run a cleaning cycle after. That would be fine. The leak check is really kind of its own standalone thing that doesn't affect the performance of the baghouse at all, except that it tells you if you've got holes. So you can do it that way.
Okay. And then we had a question from Chad, and this was concerning slide gates. Could the media being used affect flow?
In what way? So the media being used, you mean the media of the filter bag or whatever it is that's helping to seal the slide gate? I'm not sure I understand the question.
Okay, Chad, if you want to type a more detailed question into the chat module, we can follow up directly with you on that one. And then we have a question from Tim. Is it costly to do a leak detection audit of the bags or tube sheet?
No, the biggest cost really is your downtime, but the payback is not the downtime tomorrow and the next day. Leak detect powder and the procedure to run the test, depending on the size of the baghouse, for I would say 9 out of 10 collectors can certainly be done in a production day. Anything, 1,000 bags or less, one compartment or very few compartments is something that can be done in a day. So we're not talking about multiple days of downtime. And as far as the powder and the light kit is concerned, very minimal investment when weighing that next to failed bags and downtime for an upset condition.
Okay. And then we have a question from Sundar, and this was about star cages. How do you determine pinch factor for bags?
So star cages, and you can correct me if I'm wrong, Michael. Star cages are a little different in that they allow the bag to be pushed into the cage and under differential pressure, and then they're sprung back out under back pulse, so that you get more of a spring effect of the material springs out and pushes the dirt off of the material. Um, pinch would work in that you need to know what the diameter of the upper ring and the bottom ring is on a bag, so that you know that what the proper diameter is for that cage, and then you can determine a pinch from there. My guess is it's going to be the same. You're going to have material that's able to move into the spaces between the wires, so that you do get the effect of the material being sprung off the surface of the particulate being sprung off the surface of the material. So it can be determined. I would still think that we would use the same pinch guidelines, of up to 1/4 of an inch on a felt bag and 3/8 of an inch on a glass bag, or whatever it may be. I think it would be the same way. It's just that it's measuring that pinch might be a little difficult because you don't have a fully round cage. Am I right in that, Michael, or am I wrong?
Yeah, the star bags and cages are, they're built to increase cloth in a collector in what would ordinarily be a round bag and cage.
Yeah.
The peaks and valleys increase the cloth area, the surface area. So you're right, though. The same rules apply. They do need to be able to move to get the material off of that, and that's certainly something that we can help you with.
Okay. And then we have a question from Donovan. Can you go over cleaning on demand versus continuous cleaning?
Sure. So cleaning on demand would be cleaning on differential pressure. You would set your system for a low and a high differential pressure, and then once you meet your high differential pressure, the system would go into cleaning mode. In a pulse jet system, it would clean the bags in a asymmetric type order. It would go row 1, row 5, row 2, row 6, and so forth. And what that does is the benefit behind it, and maybe I didn't mention it, is that you're only cleaning when necessary, and by doing that, you're actually extending the life of the bag. By over cleaning, and it depends on the system. If you've got a system that has that you're using a regular felt bag on, and you need to build a pre-coat on, if you clean on time, you may be cleaning a system that doesn't need to be cleaned, and therefore pulsing off the pre-coat that's on the outside of that bag. So that's time and money to put that pre-coat back on. And if you don't get it to it quick enough, you'll have poor filtration. If you're using a system that, if you're using a bag that's got, say, an expanded PTFE membrane on it, you don't need to have a pre-coat. So you can in theory clean it more often, but why waste money and energy and so forth in creating compressed air and cleaning when you don't have to clean? systems that clean on demand sometimes can be reverse air and shakers and so forth, where they take them offline into a set. They take the system, they take the chamber down, they clean the system offline, and they bring it back up. That can be done sometimes on a timed basis rather than on a on-demand basis for pressure differential. But they're still, if you want to optimize that system, I mean, the movement and the shaking in a reverse air and in a shaker can cause wear as well. It does cause wear, and certain materials are used in those systems so that the bags move and don't wear as much. But if you clean them too often, you will wear them out. So we recommend cleaning on demand, in that it does save you money in producing compressed air, and you're only cleaning when necessary, especially in systems that have a pre-coat built up in the bags. The last thing you want to do is knock off that dust cake. You knock off your dust cake, then your bag's going to be inefficient, and you won't get the filtration rate that you want. You'll get material out your stack or downstream in your process, whichever it may be. Oh,
Yeah, and just to add on to that, when we're talking about pulse jet systems, that's typically what we're talking about when we're cleaning on demand. You'll know if you have the capabilities, or if your gauge has a couple of red needles in there that can be adjusted, your system is set up to clean on demand. Now, just because you have the system set up for it doesn't mean that you're already cleaning on demand. You could still be cleaning on time. But all the benefits that Dave outlined are correct. I mean, it saves you from wearing your bags against your cages with that cleaning snap of the bag to the cage. It saves you from compressed air. The biggest thing that we really see as far as a setup or even a troubleshooting perspective on these is sometimes those high level and low level red needles on your gauge are too far apart. They might be 2 or 3 inches apart. People hear that pulse jet baghouses are designed to operate between 3 and 6 inches of differential pressure. So sometimes the misconception is, okay, my high level and low level needles need to be set at 6 inches and 3 inches. We want those set points to be no more than an inch apart. So if you want your high level set point to be at 6 inches, go ahead and put that low level at 5 inches. Now you may recover to 2 or 3 inches. That's fine. But we don't want the system overburdened and just in constant cleaning mode. The goal should be that you spend less time cleaning your bags. You only want to clean your bags the minimum amount of time and frequency that's required to keep your differential pressure in line with your permit, to keep your vacuum in line with your process, your draft, I should say. So just helps keep you from overcleaning the bags.
Okay, great. And yeah, and we're getting some great questions coming in. I think we have time for 1 or 2 more. So here's a question from Rathish. What is the recommended can velocity to be maintained for pulse jet bag filters and reverse airtight bag houses?
Well, that involves a couple different things. And what the can velocity does is it allows the material to be moved off the bag when it needs to be moved off the bag. If you've some of the variables in that would be even the bulk density of your material. Is it a heavy material? Is it a light material? Will it drop off easily or not? If you have a high can velocity, very high can velocity, the material won't move off. It'll pulse, but it won't move off the bag because it can't overcome the air that's around it and so it can't get out of the bag system. So it is dependent upon the particulate in your gas stream and what you're pulling off, and then it's a function of the spacing between the bags in the baghouse, and not only between the rows, each row of bags, but between the bags in the row. So there's several different variables that play in there, and to give a blanket statement of what it should be, it's really application specific. And but typically you see can velocities that are 3,000 feet a minute. help knock off, to allow material to fall. But that's all very dependent upon the specific gravity of the material that's trying to drop out of the system. It's got to all overcome that air in the system. The system's closed, so the air stays in the system. So I don't have a better answer now, Michael. Do you have anything to add to that?
Well, just as a general rule, you're looking at 3 to 350 feet per minute as a general rule for can velocity. But keep in mind, guys, your baghouses are engineered with that can velocity in mind. And for those guys that need some help on exactly what can velocity means, what does it mean for my bags and my baghouse, please get in touch with us. That's something we can help you with. But unless you are changing your fans or your pickup points, your can velocity is not going to change from 6 years or 16 years ago when your baghouse is built to today.
Right.
Okay. And here is a question from Frank. How can you tell when you've lost the dust cake?
I'm sorry, can you repeat that question?
Oh, yep. The question from Frank is, how can you tell when you've lost the dust cake?
Yeah, okay. So the dust cake is required. Either it's a dust cake that you build on the bags. If we're talking about depth filtration, i.e. nothing with membrane on it. You guys that are familiar with expanded PTFE membrane, that's your artificial dust cake kind of pre-built into the bags. But when you're taking everything else besides membrane, depth filters out of the boxes brand new and install them in the baghouse, they're probably about 80 to 85% efficient with your gas stream, your particulate coming through. So the purpose of a dust cake is to increase that efficiency from 80 or 85% all the way up to close to 100%, which is what's required. The filter media, whether it's a woven glass or a non-woven felt or aramid, is there to really hold that dust cake. Okay, so a brand new set of bags, you'll hear things like a seasoning process. Sometimes people will pre-coat their new bags with an artificial pre-coat. Again, questions about that, we'll take them offline. We can certainly help you with that. But the goal is to have a dust cake, either your own material or an artificial dust cake set up on the bags. So when that dust cake is not there, you're going to have a very low differential pressure on your system. You might have, if your normal operating pressure on your system might be 3 to 4 inches, if you lose your dust cake, you might be less than an inch. You might have a dirty emission outlet stack. For you guys that are coming up and down per shift, you might be running for 8 hours today. You shut down overnight and crank up tomorrow again for another 8-hour shift. There's procedures in place to be able to bring those bags back into line to be an efficient filter. And any specific questions about that, please contact us after this webinar through the website, and that's something that we can help you out with.
Okay, I think we have time for one more, so this will be the last live Q&A question, and this comes from Josh. Does Minardi offer on-site baghouse audits?
Yes, we do. We have regional sales managers in our 4 different territories here in the United States, and myself and Michael, we would go out and do those as well. So we offer baghouse audits. We would come in and we would inspect your bags, your cages, your cleaning system, your discharge system, all the above that we talked about in this webinar, and we would evaluate the system and then make recommendations based upon what we see in that evaluation. So yeah, that's a service we provide, and we do that on a regular basis. We also do training on a regular basis, in-plant training for people if it's required. So yeah, that's if you need that, you can contact us offline, and we can set something up, or we can get you in contact with your regional sales manager. But we certainly do it, and we welcome it.
Excellent. Okay, so that concludes the Q&A portion. And now we will do a quick summary as promised.
So this just gives the breakdown of what we just went over with you guys, with everyone, and what to look for in when you perform your daily, weekly, monthly, quarterly, and annual checks in your Baghouse. It's just a brief synopsis. It kind of gives you a place to start when you start doing this. If you're not already doing something like this already in your plant, it might just add to what you're doing already. But this gives that brief synopsis, so you have an idea of possibly what you should be looking at and looking for as you perform these different inspections at the periodic, whatever time of the year it may be that you're trying to do them. Hopefully, this is not too generic, but it gives enough information along with what we told you about, so that you can make this useful. Michael, you have anything to add?
Yeah, and the idea behind this, guys, is as you're doing inspections, again, it's just something systematic, repeatable for you guys that works in your plant. If you like our inspection forms, you would like more information on either our inspection forms or help on how to build your own, please get in touch with us. That's something that we'd like to help you with. But as you're doing these inspections, you want to be using the data that you collect to create that recommended parts list and to summarize that into a single page, so that you have a very good idea of exactly how long this collector is supposed to last before it dies a natural death. The filters in there die a natural death, and you have to go in there and replace them. You have to replace all the moving parts, right? And so the point behind all of these inspections, all of this record keeping, is for the equipment and for your jobs to be a little bit easier and more predictable. Nobody wants to come in on Christmas Eve or July 4th and have to deal with a baghouse broken, this, that, or the other. If it's something that can be managed and predicted, kept in on a spreadsheet or kept in a data log somewhere, so that hey, look, either I can try to push these bags for another month, which will put me on Christmas Day, or I know that historically these things, last 14 months. I had to go in there on month 12 anyway because XYZ broke. Let's go ahead and take a look at these things and change them out. So that's the point and purpose behind all of this, is to try to take different baghouses in different industries, in different plants, and try to make them as routine and repeatable as possible for you guys.
Awesome. Well, thank you, Dave and Michael, and thank you everyone for attending today. This was the first webinar in our series, and we look forward to holding more in the near future. We are recording this one, and we'll send out an on-demand version if you want to rewatch. If we didn't get to your question, we will contact you directly. And if you have more questions in the future, please submit them on minorityfilters.com. There is a website contact form there. So that concludes it for today. Have a great day, everyone.
Thank you for joining. Thank you, everybody.
Thanks very much.